Okay, we're going to get started now. Hello everyone, welcome to Lesson 4 of the Algebra 2 summer classes. Today we're going to be going over fractions and rational expressions. Although this is going to be one of the shorter lessons out of the 8, I will tell you it's probably one of the most important because I cannot tell you how many times I meet with either my calculus or my physics students who should really know how to add, subtract, multiply, divide fractions, and they don't. And it makes me upset every time because this is something that you should have known since like 7th grade, in all honesty. Because adding, subtracting fractions, and multiplying is not that bad, especially once you know the rules. So that's why we're going to talk about that today. Also, for rational expressions, these are actually challenging. So, like the last few problems we see at the end of today, those are actually pretty hard, and it's probably the first time you're ever seeing these. So, be prepared for some fun stuff at the end. So first we're going to talk about adding and subtracting fractions. To add or subtract fractions, you need a common denominator. You need a common denominator. Now, what is a common denominator? A common denominator just means that both numbers have to be the same in the denominator if you want to add them. So for instance, I see here I have 3 halves plus 4 fifths. If I want to add these together, then I have to multiply 3 halves by 5 over 5 in order to get the common denominator. And then for 4 fifths, I'm going to have to multiply 4 fifths by 2 over 2. Now let's see what happens when I do that. Because 3 times 5 is 15, 2 times 5 is 10, so we have 15 over 10, plus 4 times 2 is 8, divided by 5 times 2 is 10. You get these two fractions now. And now you see that it's the same denominator, so I can actually add them. 15 plus 8 is 23 over 10. So that's the secret. But now how did I know that it should have been 5 over 5 and 2 over 2 to get the right denominator? Well, basically, if I see 2 and I see 5, and I ask myself, what's 2 times 5? I know it's 10. So in other words, I knew right away the common denominator would be 10. The question is, how do I get to 10? I have to multiply 2 by 5. I have to multiply 5 by 2. That's how I knew that was the right one to choose. And remember, whatever you multiply by the denominator, you also have to put it in the numerator, or else it's illegal, and the math police will show up at your door and knock down your house. So you don't want that. And now this next one, 1/3 minus 5/6, this one's harder, but it's the same idea. You need a common denominator. Now the question this time is, what's the common denominator between 3 and 6? Because I'm not going to do the same thing. I'm not going to say what's 3 times 6 because that's 18. The reason why is because we have a smaller common denominator. It's 6. Let me show you how we get 6. So first you multiply 1/3 by 2 over 2 because that's going to get you 6 in the denominator. And then 5/6 you're leaving the same. Don't touch it. It already has 6 in the denominator. So then this is going to reduce to 1 times 2 is 2, divided by 3 times 2 is 6, and then minus 5 over 6. As you can see, they're the same denominator, so now I can subtract them, and that's why I didn't change the 6, because it was already good. So now what I'm going to do is, I'm going to say 2 minus 5 is negative 3 over, keep the denominator the same, it's 6. And so negative 3/6, which can be reduced to negative 1/2, and that's going to be our final answer. Always try and reduce as much as you can. That's always a good idea. So are there any questions before we go on to the next few examples? Okay, good. Next one, we have 1/4 plus 2/3, and we want to add these fractions together. Again, I got to ask myself, what's the common denominator going to be here? In this case, it will be 4 times 3. 4 times 3 is 12. So we're going to have a common denominator of 12. So then the question becomes, well, what am I going to multiply by 1/4? And the answer is I need to multiply by 3 over 3 in order to get that common denominator of 12. Hopefully you're starting to get the idea. If not, let me know, because I'm assuming you get it by now. And I'm just going to go faster for the rest of these. Okay. So next is plus 2/3 times, what am I going to multiply that one by? It's 4 over 4. That's going to get me the common denominator of 12. So then I multiply these fractions together. 1 times 3 is 3 over 4 times 3 is 12. and then plus 2 times 4 is 8 over 3 times 4 is 12. And then I can say, oh, same denominator, 3 plus 8 is 11 over 12. And there's our answer. And this one cannot be reduced because 11 and 12 don't have anything in common. So that's the answer for the first one. Okay, now for the next one, 4/7 minus 1 over 6. Again, there's no real shortcut to the common denominator for this one other than 7 times 6 equals 42. So I'm going to multiply 4 over 7 by 6 over 6, and then minus 1/6 times 7 over 7, because that's going to get me the common denominator. And then how will this one reduce? Well, 4 times 6 is 24, over 7 times 6 is 42, minus 1/6 times 7 over 7, so that's going to be 7 in the numerator and 42 in the denominator. Same denominator, now I can subtract these. 24 minus 7 is 17 over 42. Does that reduce? No, because they don't have any factors in common. So that's our answer, 17 over 42. Now for the next three, you're going to notice that the common denominator is not, for instance, 12 times 4, which, is 48. 12 times 4 is not the common denominator because if you think about it, 12 is going to be the common denominator because 4 times 3 equals 12, and 12 is already good. So that's how you can save some time. If, for instance, you didn't know that, like let's say you did 12 times 4 and 4 times 12 and you get a common denominator of 48, you'll still get the right answer eventually. You're just going to have to do a lot of reducing, and I don't like reducing because that's a lot of work. So we're not going to do that if we can avoid it. So in other words, it's 13 over 12. Don't change that fraction because we already have 12 as the common denominator. And then plus 3/4, I'm going to multiply by 3 over 3 because that's going to get me a common denominator of 12. So for this one, it's 13 over 12 plus 3 times 3 is 9, divided by 4 times 3 is 12. We'll get a final answer of 13 plus 9 is 22 over 12, which can still reduce to 11 over 6 because they're both divisible by 2. And it looks like that's going to be the answer for number 3. Any questions on that one? Okay. Now for number 4, not number 5, but number 4, how about you try this one on your own? And if you have any questions, let me know. And if you're watching the recording, pause the video and try it. We're going to do number 5 together because I want to. But go ahead and do number 4 on your own. Another 15 seconds. If you don't finish it, it's fine. We're going to go over it anyway. And time's up. So for this one, you have to realize that the common denominator will be 25 because 5 times 5 is 25. And so that's kind of the secret and the hint here is that you're going to multiply 6/5 by 5 over 5 to get the common denominator of 25. And then minus 6 over 25. Don't change that. You already got 25. And then we start reducing. So 6 times 5 is 30 over 25 minus 6 over 25. And 30 minus 6 is 24. 24 over 25 is going to be our final answer. Any questions on that one? And then the last one, maybe you can do it on your own, but either way, I don't care. I want to explain this one because this one, the common denominator is probably the hardest out of the 5 we've seen so far. So here's what I would recommend. I know for a fact that 6 times 8 equals 48, and that is not going to be the smallest common denominator. Why not? Because I know 6 and 8 are both divisible by 2, so I know there's going to be something in between here that's going to make it easier for myself. Now, what I'd recommend here, if you feel like there's going to be a common denominator less than 48, for instance, write out the first few factors of 6 and 8. Like what I mean is you've got, I don't mean factors, I mean multiples. So you got 6, you got 12, you've got 18, you got 24, you got 30, the list goes on and on. Then do the same thing for 8, count by 8. You got 8, 16, 24, stop. And the reason I say stop is because now we have a number in common. It looks like the least common denominator is going to be 24. And how you get that is you need to multiply the 6 by 1, 2, 3, 4, so times 4. And you're going to multiply 8 by 1, 2, 3 times 3 to get 24. So in other words, it's going to be 3 over 6 times 4 over 4. That's going to get me 24 in the denominator. And then minus 5 over 8 times 3 over 3, because that gets me 24 for the 8. And now I'm going to reduce 3 times 4 is 12 over 24 minus 5 times 3 is 15 over 24. 12 minus 15 is negative 3 over 24. And then both of these numbers are divisible by 3. 3 over 3 is going to be negative 1. 24 over 3 is going to be 8. It looks like the answer is negative 1 over 8. Any questions on that one? Okay, good. Then the next thing we're going to talk about is, oh, go ahead. Hello? No? Okay, never mind. Okay, so next we're going to talk about multiplying and dividing fractions. So, when it comes to multiplying and dividing fractions, we've kind of already done this actually when we added and subtracted. Basically, if you want to multiply, you just multiply the numerators together. So 3 times 4 is 12, divided by 2 times 5 is 10. This reduces because they're both divisible by 2. And so the final answer is 6 over 5. And so that's pretty easy. And then for dividing, here's where you need to remember something. If you want to divide, flip the second fraction and multiply. That's the secret to dividing. Flip the second and multiply. In other words, this is the same thing as 3 halves times 5 over 4. Because I flipped the second fraction. It's also called the reciprocal, by the way. That's called the reciprocal. When you flip, it's called the reciprocal. So 3 halves times 5 fourths. Now the same idea. 3 times 5 is 15. 2 times 4 is 8. Does this reduce? No. So we're done. And the one thing I'm going to advise you to do, especially for the more complicated examples, like these ones are pretty easy, okay, so it didn't matter. But I'm going to force you today to reduce your fractions before multiplying or dividing. And the reason why is because of this example right here, 24 times 5 over 25 times 8. That's pretty big math. I don't really like doing these numbers in my head. But if I can reduce it, then it helps me a lot. And the way you reduce is that it needs to show up in the numerator and the denominator. Let me show you. You see how 5 and 25 here, they're both divisible by 5? So if I divide 5 by 5, I get 1. And 25 divided by 5 is 5. And there, I've already started reducing because one shows up in the numerator, one's in the denominator. Same idea with the 24 and the 8 here. They're both divisible by 8. So 24 divided by 8 is 3. And 8 divided by 8 is 1. So really what we have here is 3/5 times 1 over 1. And so that's just going to be 3/5 if you multiply across. And by the way, if you did it the long way, if you did 24 times 5, which is 120, divided by 25 times 8, which is 200, it's eventually going to reduce to 3/5. But it takes a lot longer. And if we can avoid that, then we definitely will avoid it. Any questions there? Now, one thing I just want to point out real quick, if I erase these marks I made, you'll notice that I multiplied across like this, and like that, that's how I reduced. This is not the same thing as cross multiplying. I repeat, this is not the same thing as cross multiplying. Cross multiplying is something you do when you have an equal sign in the middle. That's when you cross multiply. So then what did I do, right? If I didn't cross multiply, what did I do? I just reduced. I reduced because technically, because this is multiplication, it's really 24 times 5 in the numerator and 25 times 8 in the denominator. It's all one big happy fraction. And you can reduce fractions as long as it shows up in the numerator or the denominator. So in other words, if I wanted to reduce like this and like this instead, that is absolutely okay because one shows up in the numerator, one shows up in the denominator. The reason why I didn't do that is because these fractions I just circled do not reduce that way. It looked like they only reduced across, which is fine. They can reduce any way you want as long as you're not reducing. Don't reduce like this because that's illegal, because that's the numerators and denominators separately. You need to have a mix and match, one in the numerator, one in the denominator. Hopefully that makes sense and I'm not confusing you. If I am, please tell me. But I think these examples we're about to do are going to clear things up. So again, same idea. When I have this, the first thing I'm going to ask myself is, does anything reduce in the numerator and denominator? The answer is yes, because 21 and 7 are both divisible by 7. 21 is going to reduce to 3, and 7 is just going to reduce to 1 when you divide both by 7. And then 2 and 5 do not reduce, so don't try to. It won't work. So in other words, in the numerator, I now have 2 times 3. In the denominator, I have 1 times 5. And then this is super easy. The answer is going to be 6 over 5 when you multiply across. Any questions on that first one? Okay, then good. Now let's do the next page and we'll do some harder ones. Next, number 2. 9 halves times 6 over 15. So again, it looks like I have 9 and 15 are both divisible by 3. 9 over 3 is 3. 15 over 3 is 5. And then 6 and 2 are also divisible by each other. Like they're both divisible by 2. 6 over 2 is 3. 2 over 2 is 1. It looks like this is going to reduce to the numerator, which is now 3 times 3, divided by 1 times 5. And then that's just going to equal 9 over 5. And there's our answer. Any questions? Okay, then for the next one, number 3, we're going to be dividing. Remember, dividing is the same thing as multiplying by the reciprocal, just like that. As a matter of fact, do not try and reduce before you do that. In other words, if you say, hey, I can reduce the 3 and the 9 because they're both divisible by 3, do not do that. That's illegal because the first thing you need to do is multiply. And the reason why is because now you say, oh shoot, I can't reduce those. They're both in the denominator. As a matter of fact, nothing reduces here. Nothing does. So in other words, 4 times 5 is 20. 9 times 3 is 27. That does not reduce. We're done. Any questions there? And then number 4, the last one. This is known as a complex fraction. And I'm not just saying that because it looks complex, which it definitely does. This is actually the actual word you use. You call it a complex fraction whenever you have two fractions on top of each other like this. The good news is it's the exact same thing that we just did in number 3. In other words, you're going to write it as 12 over 10 times the reciprocal, 5 over 16. Flip the second fraction and then multiply. And now we ask ourselves, do these reduce at all? Well, 5 and 10 are both divisible by 5. 5 over 5 is 1. 10 over 5 is 2. And then 12 over 16. Those are both divisible by 2. So 12 over 2 is 6. 16 over 2 is 8. And then we have this. We have 6 times 1 over 2 times 8. As a matter of fact, you can still keep playing this game. In other words, 6 and 2 are both divisible by 2. So that goes to 1. 6 goes to 3. And you'll get a final answer of 3 over 8. Which, by the way, just to show you an alternative way of getting the right answer, at this step right here, when I wrote 6 times 1 over 2 times 8, you can also just multiply right now. You don't have to reduce constantly. You can say 6 over 16, and then that reduces because they're both divisible by 2. You can say you get 3 over 8 that way as well. And there's more than one way to get the right answer here. The reason why I recommend reducing is because it's going to make your multiplication easier. And it's also a good strategy in general for the next topic we're going to talk about, which is rational expressions on the next page. But before we get there, any questions on multiplying and dividing fractions? Okay, good. We're already on to the last topic of today. I told you it'd be a short one, but it's a good one, and there's plenty of great homework problems for you to do after this. So with rational expressions, I gave you some examples of what they look like. Yes, they look very complicated, but all of them have one thing in common. Well, more than one thing in common. But here's the thing I want you to realize. Rational expressions have an x in the denominator. They have an x in the denominator. Yes, some of these also have an x in the numerator, but the middle one doesn't. In other words, the numerator is optional. Numerator is optional. A lot of times you will see rational expressions with an x in the numerator and denominator, but what makes a rational expression? It needs to have an x in the denominator specifically. And then, of course, that begs the question, what can we do with these rational expressions? There's three things you can do. One is you can multiply them together, just like we were doing earlier with fractions. Two, you can divide them, which is, again, very similar. We're going to do the flip the second and multiply, just like we did before. And the third thing we can do, and this is the most important, you can factor them and reduce. And I'm putting them into one category because we're going to do it basically in one step. So these are the three things we're going to be doing with the examples below. Before we actually get to the real examples, here's a quick example to show you what I'm doing. So I'm not even going to read this out loud. I'm just going to ask you to look at it. The goal here, when you're multiplying, is not to distribute. I'm just going to tell you right now, don't distribute. That's not the right thing to do. Okay? You technically can distribute. I'm asking you not to. It's not worth it. You don't have to. You won't have to in Algebra 2 either. What you do want to look for is you want to look for things canceling because they show up in the numerator and denominator. Look for things that cancel. We're looking for things that cancel. So for instance here, I see two things that cancel. The first one is the x minus 5 in the numerator and the x minus 5 in the denominator. Does anyone see the second thing that cancels? The answer is the x cubed and the x. Now you have to be careful with this because this is not so obvious. If you want to cancel x cubed over x, you need to first of all remember that that's x to the first, like there's an invisible 1 there. And if you want to cancel them, it's like that cancels all the way, the x is gone, and this cubed will now become squared because you took 1 away from it because the denominator only had a 1. So in other words, what's my final answer going to be? Well, what's left in the numerator? We have an x plus 2, we have x squared now, and we also have that x plus 3 in the numerator as well. In the denominator, it looks like everything canceled, which means technically it's not over 0, it's going to be over 1 whenever that happens. And since anything divided by 1, you don't need to write the 1, the correct answer is x plus 2 times x squared times x plus 3. And there's our final answer. Yes, technically you can distribute, but I said at the beginning, don't. So there's our answer. Any questions there? And by the way, one more thing I want to mention. If, for instance, I had the opposite, I had 1 over x plus 2 times x squared times x plus 3. If I had this one you cannot get rid of that 1 because that would completely change the equation. So if you had 1 over this, you would circle this and it would be the final answer. Just wanted to point that out in case that ever happens. But any questions on that? Okay, great. Next, let's look at some of the examples. Simplify the rational expressions as much as possible. Okay, so again, for this one and the rest of them, I'm just going to try and cancel as much things as I see. So for instance, the x minus 2 cancels. It looks like the x minus 3 cancels. And that's it. Nothing else cancels. So then in my numerator, what's left? I've got x plus 6 times x plus 11. And in the denominator, I have x plus 1. Notice I need to put parentheses in the numerator because I'm multiplying like this. And if I missed the parentheses, I would be saying completely did something different in math speak. But in the denominator, since it's just x plus 1, technically I can put parentheses. But honestly, I would recommend not doing that because it's actually not the cleanest form. This is the cleanest form. The only time I would need to put this in parentheses if there was something else in the denominator, let's say a 2x, for instance, or whatever. That's when you would need parentheses around there. But it doesn't matter that much. That's just a notation thing. If you forget that, it's not the end of the world. You'll still get the right answer. But any questions on that first one? Okay, good. Next, we have x plus 4 over x minus 1 times x squared minus 1 over x minus 4. Can someone tell me what cancels here? Yeah, so for this one, you'll notice nothing cancels yet. But you see the x squared minus 1 right here, that can be factored. And hopefully we remember from lesson, I think it was lesson 2, where we talked about factoring. Well, x squared minus 1, that's going to factor to x plus 1 times x minus 1. And of course, if you don't get it as fast as me, that's fine, but you do have to get this far eventually, even if it takes a minute or two. So now I'm going to rewrite it with my new factors. In the numerator, I have x plus 4 times x plus 1 times x minus 1. Again, all that's in parentheses. And then in the denominator, I have x minus 1 times x minus 4. Now does anything cancel? One thing and one thing only, the x minus 1s. So then that's what the final answer is basically going to be. It's going to be x plus 4 times x plus 1 divided by x minus 4. And again, in the denominator, since it's the only thing, I don't need the parentheses. Now, question for you guys, x plus 4 divided by x minus 4, it almost looks like it cancels. Is there any way I can reduce that? And the answer is no. No, I cannot. This is the only correct answer that I will accept. And that's that. Any questions? Okay. Number 3, it looks like we're upping the ante here, a little bit tougher. So for this one, I want you to realize there's two things that cancel. First of all, with the x minus 5, they will partially cancel. In other words, x minus 5 in the numerator, that's gone completely. But x minus 5 cubed is just going to come down to squared because you took one of your x minus 5s away. Now for the x to the 6 and x squared, same idea. X squared goes away completely. You need to take away 2 from the 6th power, leaving you with 4. So in other words, in the numerator, I'm just left with x to the 4th. In the denominator, I have the quantity x minus 5 squared. Yes, you do need parentheses around that, or else you're saying something different in math. And this cannot be reduced anymore. That's our final answer. Now, by the way, I think it's worth mentioning, because I don't think I ever mention it in this lesson. If, let's say you had x minus 5 cubed times x minus 5, like this, well, this is when you would add the powers together instead of subtracting them. In other words, this would now be x minus 5 to the 4th power. And that's just something handy to know. We're not going to use that today or in the homework, but it's so similar that I thought I'd mention it. Okay, now let's move on. Number 4, we have division. So the very first thing I do before I do any math is I'm going to rewrite this as x squared minus 5x plus 4 over x minus 4 times the reciprocal, x squared minus 2x minus 15 divided by x plus 3. I just turned division into multiplication and I flipped them. That's it. Now the next thing I need to do is I need to factor the two x squared things. Like for instance, x squared minus 5x plus 4. I bet the factors are going to be 1 and 4 because that adds up to 5. And I bet they're both going to be negative because that needs to be negative 5. And again, if this takes you longer than me, that's completely fine. I expect it to take longer than me. I've been doing this for 15 years now. But it's going to be x minus 1 times x minus 4. Then for the other factor was x squared minus 2x minus 15. And that's going to factor to, I bet the factors are going to be 3 and 5. And since it's minus 2 and it's minus 15, I bet I'm going to subtract them. So in other words, it's going to be x minus 5 times x plus 3. That's going to be the right factors. And so then I'm going to rewrite it with all my new fancy factors. I've got in the numerator x minus 1 times x minus 4 times x minus 5 times x plus 3. In the denominator are the two things that were already there. It's x minus 4 times x plus 3, just like that. And now you'll see that the two things cancel. X minus 4 cancels and x plus 3 cancels. And so what we're left with then is we're going to get x minus 1 times x. I think I'm on the wrong page. Hold on. X minus 1 times x minus 5 divided by 1, and you don't even need to write the divided by 1, So you can just write x minus 1 times x minus 5. And there's the right answer for that one. Any questions? Okay. And then the very last one of the day, it will probably be the hardest, and I bet you it is. This monstrosity. So again, first thing I'm going to do is I'm going to rewrite it by flipping the second fraction and then multiplying. So in other words, it's going to be times x squared minus 1 divided by x cubed times x plus 1. So again, I need to factor anything that I see has an x squared in it. It's funny, this thing technically has x squared, but that cannot be factored. I'm talking about this stuff like x squared plus 7x minus 8. So x squared plus 7x minus 8. That is going to be the factors 1 and 8, which gets me to positive 7 when I subtract them. So in other words, I bet it's going to be x plus 8 times x minus 1. And then is everything else factored? Nope, I still have x squared minus 1 to take care of. So x squared minus 1, we actually just did this a minute ago in the other problem. It's going to be x plus 1 times x minus 1. And then again, I put this all together in one beautiful fraction. X squared times x minus 1 to the 5th times the x squared minus 1 is x plus 1 times x minus 1. That's the entire numerator. And then the denominator, I have that factors, which is x plus 8 times x minus 1. And then also in the denominator is an x cubed and an x plus 1 from the other fraction. And now I have to ask myself what cancels. Looks like x minus 1 cancels there, x plus 1 cancels there, and one more thing is going to cancel. It's the x squared over the x cubed. The x squared goes away completely, and then I have to subtract 2 from x cubed. It looks like that's going to be x to the first, which I don't even have to write x to the first. I can just write x. So in other words, what's left in the numerator? X minus 1 to the 5th power. In the denominator, the quantity x plus 8 times just x to the first, which is just x. And that's going to be our answer for the last one. Any questions on that? Okay. Well, then in that case, that's the end of the lesson. Thank you all for watching. If you do have any questions, you can stick around or post in the comments below if you're watching the recording. Thank you all for attending, and I'll see you next week for Lesson 5. Take care, and bye-bye.